So to find our average rate of change on the interval 0 to 3, what do we have to do? Right. Should just be a slope, right? That's what an average rate of change is. A of 30 minus A of 0 over 30 minus 0. And what did that come out to be? It looks like they came out to be negative 0.197.
Yeah.
And it says indicate units of measure. So our units of measure, this is pounds per day. What did you put? Pounds per? You put pounds per second. Okay, wonderful. All right, so see this. See it right here. The word days is spelled D-A-Y-S, and seconds is S-E-C-O-N-D-S. So this is the word days. That is some really. I mean, that is some impressive decomposition. If you're doing that in pounds per second, I mean, I don't know what sort of chemical process you've started, but
It just disappears in front of your eyes.
yeah, it's magical decomposition. Okay. Part B, find the value of A prime of 15. That should be easy enough. The point distribution for that was 1 point. Or answer with units. Part B, to find A prime of 15. Just plug that into your calculator. A prime of 15 came out to be negative 0.164. It says or negative 0.163. I don't know why you get two different values there, but that's what it says. So either of those would be good. And then what does it say? Using correct units, interpret the meaning of this value in the context of the problem. So this is the derivative of A. A is the amount of grass clippings in the bin. So that should be the rate of change of that. Right? So we would say that, I don't know, something to the effect of that that's the, we'll just say it's decreasing at 0.164 pounds per day at day, what was it, 15? Yeah. So we'd say amount. We probably might include amount of grass clippings. Good. That was worth 2 points. One for the value, one for the explanation. Easy enough? Everybody was good with A and B, I hope. All right, part C, we want to find the time at which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin. Well, to figure out when that's true, we have to figure out the average amount of grass clippings in the bin. How do you find the average of the amount of grass clippings in the bin? One over, it did say 30 though, still for 30, right? Yeah. So 1 over 30 minus 0 times the integral from 0 to 30 ought to be the average amount for A of t dt. And what do we need to set that equal to? We want the average amount to be equal to the actual amount. We need to set that equal to A of t. So this is a value you should be able to come up with. That value came out to be, then the squaring guide doesn't tell me what that value came out to be. It just tells me the t value, which this is true. So this came out to be something. Set your function equal to that number, and then use your graphing calculator to solve that equation. Came out to be 12.415. How we feel about that? Days. You good with that, Derek, or no? You didn't get A right? So sad. And that was worth 3 points, no, 2 points. That was worth 2 points. One for this, for using the mean value thing for integral, and then one for the answer, for setting it equal to. You good with that, Ben, or no? Yeah? Okay. People in the Zoom, are you good with that?
Yes.
Zoom good? Good, Zoom. Okay. All right, part D, what was I even asking? Oh, linear approximation. All right, so for t greater than 30, L of t, the linear approximation to A at t equals 30 is a better model for the amount of grass clippings in the bin. Use L of t to predict the time in which there will be a half a pound of grass clippings remaining in the bin. So first off, what's linearization? We have to use the derivative at t equals 30 to figure out the slope of this thing. So first we'll figure out what was a prime of 30. A prime of 30 and came out to be, what does it say here, negative 0.055976. So we'll use our linear approximation at 30, and then what was the value? We need to find the value at 30, because we'll need that for our linear approximation. Also, what was the value at 30? 0.72928. Okay. And so your linearization, L of t, we'll say, your L of t ought to equal your value at A, or value of A at 30, so A of 30, plus A prime of 30, times our t value minus 30. And that's the linearization formula. The function, the original function at the value that you're using your approximation at 30, plus the derivative at 30 times your new value minus 30. Everybody good with that? And then what did it ask us to do with that? Figure out when it was equal to a half a pound of grass clippings in the bin. So just set that equal to a half. And solve for t, which looks like that came out to be 35.054. Just by plugging that into your calculator. Everybody okay with that? That was worth 4 points. 2 points for the expression for L of t. 1 point for setting it equal to a half, and 1 point for the final answer. Everybody get there? Derek? Yeah. Zoom, good.
Good Zoom.
Good Zoom. All right. What do we think? We did decomposing grass. We could do coffee. You guys want to do coffee with the chart? Or we want to do taking a bath with a chart? Or not either of those with a chart? Or drinking, we could do drinking tea with a chart and eating biscuits. I think we should do this one. Let's do this one because this includes a little bit of what do you call it? Series stuff also. It's got a Taylor polynomial stuff there at the bottom. It's also got Euler's method, which we get through practice. So we kind of throw some things at you that we might not have done a ton. So let's do this one. I like this one. Maybe we'll go back to a different one. This is the 4th one in that packet. I will give you 15 minutes and then we will go through it. Ready?
Yeah.
All right, first part A, tangent line. That should be easy. Tangent line should be easy. You need a slope and you need a point. We're talking about, no, not talking about 1.4. We're talking about x equals 1. So our point is 1,8. And our slope is, sorry, no, our point is 115. I can look. 115 and our slope is 8. So we should just have y minus 15 equals 8 times x minus 1. And we're going to approximate 1.4 with that. So 1.4 minus 1 is 0.4. 0.4 times 8 is what? 3.2 plus 15 ought to be 18.2. That was worth 2 points. 1 for the tangent line, 1 for 18.2. Everybody good with that? No, not part C. I'm having some trouble with letters today. Part B. Midpoint Riemann sum, 2 subintervals equal length to approximate the integral from 1 to 1.4. So 2 subintervals using the midpoint. So we're 1 to 1.2. We're going to use the midpoint at 1.1. So that'll be a height of 10 with a width of 0.2. And then we should have a height of 13 with another width of 0.2. And is that all it asks? Oh, use the approximation So use the approximation to estimate the value of f of 1.4. Okay, so we've integrated from 1 to 1.4, which tells us how much it changes. And so then what should we do with this? Well, first off, what's this value? That value should be 4.6, right? And then we're estimating the value of f of 1.4. So how do we find the value of f of 1.4 using this integral? Right. F of 1 plus 4.6 is approximately equal to f of 1.4. So that ought to be, what was f of 115, right? So 19.6. And that was worth, wow, that was worth 3 points. One for this, one for using the initial condition, one for that final point. 5 points from A and B. Pretty straightforward for A and B. People at home, are you good?
Yeah.
Good Zoom. Yeah, everyone's good. That's good. Okay. All right, part C asks us to do Euler's method starting at x equals 1, 2 steps of equal size. So Euler's method, we'll make ourselves a little chart here. We know we're starting at 115. And the first thing that we need to do is, what is that, 2 steps, right? Yeah, 2 steps. So 1 to 1.2 and 1.2 to 1.4. So what's the slope at 1? The dy dx at 1 is 8 times our step change in x, our delta x is 0.2, right? So it's, I guess I should have left myself more room to go a bit smaller. 8 times 0.2, that'll be 1.6. So that is how much our y value is going to change, right? This is delta x times dy dx, or times x. I don't really need all of this. So we're going to go from 1 to 1.2 and from 15 to 16.6. Everybody go with that? Ben, you go with that? You sure? But you're good now? Yeah. Okay. All right. That was funny. You said you screwed up this one, so I want to make sure. Okay. Frustrated with how easy it is. Yeah. All right. So next time our delta x here is again going to be that 0.2, but now our slope is the slope at 1.2. Our slope at 1.2 is 12. So we'll go in and do 0.2 times 12. This time that gives us what? 2.4. And so we'll just add that. So that's going to give us 1.4, looks like, comma 19. I think it asks what is the, yeah, approximate f of 1.4, 19. Good? Everyone good with that? That was worth 2 points. I'm not sure exactly how they really break this down. They say Euler's method with 2 steps is worth 1 point, and then it says answer 1 point. I don't know. I guess if you made an attempt but did the arithmetic wrong or something, maybe they'd give you the point for doing 2 steps with Euler's method, but not give you the point for the answer. So 2 points. All right, and then part D, what was part D? Using a second degree Taylor polynomial for f about x equals 1. So first off, we need to know f of 1, which we know f of 1 is 15. We know f prime of 1, that's 8, and we're going to need f double prime of 1. I sure hope they gave us that, or else we'll have to approximate it. Looks like it's 20. Great. So in order to write this out, it should be f of 1 plus f prime of 1 times x over 1 factorial, and then plus 20 times x squared over 2 factorial. Really good? And that's all it said. It was just to use that. Oh, yeah, sorry. We're doing it at x equals 1. You're right. X minus 1. Sorry. My fault. Yeah, x minus 1 squared x. Yeah, thank you. I thought so too. All right. Looks good to me. All right. It's a square. It's supposed to be on top of it. Yeah, I agree. Okay. And then what are we approximating? 1.4 again, I assume. Yeah. So 15 plus 8 times 0.4 plus, this is 10, 20 over 2 factorial, times 0.16, 0.4 squared. So it looks like that gives us what? 15 plus 3.2, it's 18.2 plus 1.6, 18.2, 19.8. Sound good to everybody? Yeah. 2 points. One for the polynomial, one for the value at 1 point. Everybody good there? People at home, are you good? That's a fun one, huh? It's exciting.
Yeah.
Yeah, yeah. This one was 2012. The previous one, I think, was 2016, I want to say, but it might have been 14, but it might have been 15, but it might have been 18. It was something. Anybody have a preference between coffee and a bathtub?
I am drinking coffee right now.
All right, we'll do the one with the tea. Sounds
That's
good.
great.
All right, let's do the problem with the tea. I am drinking tea right now. All right. Everybody good? A pot of tea is cooling. I believe in the list it's number 5. Let's see, 1, 2, 3, 4. Yeah, it's number 5. Then number 5 on the miscellaneous sheet. What time are we out of here? 20, 27. All right, you better hurry up. Ready to go.